Alright everyone, this is continuing on in section 5.1, and now we're going to learn about inverse cosine. So let's first draw the cosine function, and if we do that, you get a function that looks something like this. Now, of course, that is not one-to-one as it is, so you have to, we're going to have to restrict it just like we did sine. The only problem is we can't do negative pi over 2 to pi over 2 because this is negative pi over 2, this is pi over 2. So it would still be would not be a one-to-one function if we did that. So we have to restrict the domain a little differently for cosine. We're going to restrict it from 0 to pi. From 0 to pi. And that will give us a one-to-one function there. So what we say is that the inverse of cosine when it's restricted from 0 to pi is y equals the inverse cosine of x, or y equals the arc cosine of x. So this would be equivalent to, again, just like with sine, the cosine of y equals x for all the y in this interval. For all the y's in that interval. Alright, so the inverse the inverse cosine of x is the number or angle y when cosine is x. Okay? What angle gives you a cosine of x? Okay, so for instance, and just like sine, you can do the graphs much the same way. You can do the t-chart and then reverse the points, and the graphs look much the same. For instance, right here, this would be the graph of y equals cosine x, and the domain would be from 0 to pi, and the range would be, of course, from -1 to 1. Now that reverses just like with sine when you do the inverse. Of course, this is actually our 0 and our 0 and pi are actually on the y-axis this time. -1 and 1 are actually on the x-axis, just like with sine. And so you end up with something that looks like this. Okay? And so the domain, if you remember, is the range of the original function, and the range is the domain of the original function. Alright, so still follows the same suit. And much the same way, we have some identities that you need to know. The cosine of the inverse cosine of x equals x when x is between -1 and when x is between 1. The inverse cosine of the cosine of x equals x when x is between 0 and pi. When x is between 0 and pi. So we're going to use those much the same way we did the sine identities. If you look at your exact values, let's work a few examples just like we did with sine. So, for instance, let's look at the inverse cosine of 1/2. So, where does cosine of y equal 1/2? So, I kind of like the whole reference triangle way of doing this. Excuse me, I'm sorry about that. I kind of like the reference triangle way of doing this, where we know it has to be between 0 and pi, and so what we have to do is figure out what angle between 0 and pi has a cosine of 1/2. So very easily we can do this with a reference triangle. This is 1, this is 2, this is the angle y, and if you do the Pythagorean theorem, you'll get that to be the square root of 3. So what angle on your unit circle has a cosine of 1/2 but has a sine of square root of 3 over 2. We can use that with our reference triangle, and very easily you're able to think, okay, well that's pi over 3. So the cosine of what angle gives us 1/2? Well, that would be pi over 3, just like that. So you can use the reference triangle to get it. I kind of like that method. I also like using the reference triangle to get our points, our x and y points here, using our 1 over 2 and square root of 3 over 2 for the sine value, for the y value. I like doing that because then I can relate it to a point on the unit circle, okay, to an angle on the unit circle. I really like that as well. So whichever way is going to allow you to get it correct. All right, so let's look at another one. Let's look at the arc cosine of negative square root of 3 over 2. The arc cosine of negative square root of 3 over 2. Okay, well, what we're going to do here is we can do much the same thing. This is the same thing as the cosine of y equals the negative square root of 3 over 2. So think of it like this. What angle between 0 and pi, because that's our restricted domain, remember, what angle between 0 and pi has a cosine of negative square root of 3 over 2. Now, if you're good with your unit circle, you're going to be able to figure that out very easily, okay? So what we need to do here, if you can't figure that out, is to draw your unit circle, and is to draw your reference triangle, excuse me. So this is cosine, would be negative square root of 3 over 2, so that would give us a sine of 1 here. So this would be the point negative square root of 3 over 2, 1/2. So figure out what angle on the unit circle has that, okay? And so you figure out very quickly that it's 5 pi over 6. 5 pi over 6. Okay, so this whole thing would be 5 pi over 6. Now, why can it not be negative 5 pi over 6, even though the cosine, a common answer for this is negative 5 pi over 6, because the cosine of negative 5 pi over 6 is negative square root of 3 over 2. Number one, when you set your point up, you can relate it back to the angle, and you won't have to wonder about negative 5 pi over 6. But if you don't do any of this and you try to just do it in your head, you're going to come up with two angles, okay, for a lot of these. So you're going to have, there are two angles that have a cosine of negative 3, square root of 3 over 2, or well, more than two, but two that come to mind very quickly. One of them is negative 5 pi over 6. Why can that not be an answer? Well, think of what your domain is. Your restricted domain is this right here. Negative 5 pi over 6 does not fall in that restricted domain. But like I said, you don't have to deal with that if you use your reference triangle to get your point, just like we did here. Okay? Use your reference triangle to get the point. Use the point to relate back to the angle. That's going to be an easy way for you to get it. Alright, so let's look at another one. Let's look at the cosine of the inverse of cosine of 0.7. Now, before you haul off and say it's 0.7, remember your rule. The cosine of the cosine inverse of x equals x if our x value is between negative 1 and 1. So if our x value is between negative 1 and 1. Well, 0.7 is between negative 1 and 1, so we can say that this answer is 0.7. Very quickly, very easily. Okay? Remember, you always have to check when you're doing the cosine of an inverse or the inverse of a cosine. You're always having to check. Okay? So let's look at this one. Let's look at the cosine, the inverse cosine of the cosine of 5 pi over 4. Well, remember the rule for this. The inverse cosine of the cosine of x equals x if x is between 0 and pi. So, if you look at this right off, okay, 5 pi over 4 is not between 0 and pi. Okay? 5 pi over 4 is not between 0 and pi. So what does 5 pi over 4, the cosine of 5 pi over 4, equal? So think about that a second. The cosine of 5 pi over 4 equals negative 1 over the square root of 2. So what angle in this interval right here has a cosine that's negative 1 over the square root of 2? Well, the angle in that interval that has a cosine of negative 1 over the square root of 2, or negative square root of 2 over 2, depends how you learned it, is going to be 3 pi over 4. So what we say is this answer here. So the inverse cosine of cosine is 5 pi over 4 is going to be 3 pi over 4. 3 pi over 4. So keep that in mind. Now, essentially what we did there, folks, is we asked this question here. What is the inverse cosine of negative 1 over the square root of 2? So we found the angle in 0 to pi that had a cosine of negative 1 over the square root of 2. That's essentially what we did there. Okay? So you had to ask yourself, the cosine of y, where is the cosine of y? This answer. And that's at 3 pi over 4 in this interval. Okay? So remember, we equated these two angles. The cosine of this angle is negative 1 over square root of 2. So what angle in this interval has that answer, and it's 3 pi over 4? That's how we answer that problem, when it doesn't just fall in our interval like we're used to. Alright, so here's one like we had last time that I think I may have been a little confusing on. And it's this one. The sine of the inverse cosine of negative 1/3. Alright, so, well, let's let y equal the arc cosine of negative 1/3. Okay, and this same methodology can be applied to the sine one that may have been a little confusing in the last video. So essentially what I'm saying is, where is the cosine of y equal to negative 1/3? Well, and that's between 0 and pi. So draw your reference triangle. So that's negative 1 over 3. So use your Pythagorean theorem to get the other side, and that's going to be 2 square roots of 2 when you get the other side. Now, this is what I was trying to explain to you a moment ago. We used this to get our reference triangle. Now, this ends up being our angle of sine. So this ends up being the angle. Okay? So using this reference triangle that's based off the inverse, we can find our sine of our angle. So what is the sine of this angle? It's opposite over hypotenuse, which is 2 square roots of 2 over 3. So notice we took the inverse, we used the inverse to get the reference triangle, and then used the reference triangle to get the sine of the angle. Okay? That's what I was trying to explain to you in the last video with the other version of this problem. So hopefully this is a little more understandable. Okay? Hopefully so. Alright, so again, you have some calculator examples on page 296. Make sure you go through those and can type them in the calculator. And folks, when you're looking at your solutions, make sure your calculator, if it's a radian problem, make sure it's set in radian mode. And also, if I'm asking you, one thing I noticed on exams, if I'm asking you for 4 significant digits or 4 decimal places, please, folks, make sure that you give me 4, alright? So, let's look at one other problem, and then this will end the cosine version of this, and we will get to the tangent. Alright, so what if I give you the cosine of the arc sine of 3/5 minus the cosine, or minus the arc cosine, excuse me, of 4/5? Now, when you get ready to solve this problem, the first thing that should jump off the page at you is that this is a difference identity. The cosine of x minus y equals the cosine of x times the cosine of y minus, or excuse me, plus the sine of x times the sine of y. So, using this as my x and this is my y, I have the cosine of the arc sine of 3/5 times the cosine of the arc cosine of 4/5 plus the sine of the arc sine of 3/5 times the sine of the arc cosine, or the inverse cosine, of 4/5. Alright, so when you're doing this, now it's just a matter of solving problems. So how do we solve this one? And how do we solve this one? Well, these are two like the very last one I showed you. We use the inverse to get the reference triangle, and then use the reference triangle to get the cosine. So if we're looking at this, alright, so 3/5, where sine is 3/5, that would have to be 3 here, 5 here. Remember, because arc sine has to be between negative pi over 2 and negative pi over 2, so it's going to be in the first or fourth quadrant. And so once you do the Pythagorean theorem, you get your 4 for that side. So we used this inverse here to get our triangle. Now use the triangle to find your cosine. So the cosine of that triangle is 4/5, adjacent over hypotenuse, 4 over 5 times. Okay, now this is one of our identities. So remember, cosine of a cosine inverse. If you look back at what I explained about this, cosine of inverse cosine, this has to be between -1 and 1 for the identity to apply. Well, 4/5 is between -1 and 1. So because of that, the identity applies. So the cosine of the inverse cosine is just 4/5, because the identity is able to apply, because 4/5 is in the domain right here. It's in that range. Plus sine of an inverse sine. Now remember that's one of our identities as well. And sine of an inverse sine has to be between -1 and 1 as well. And if you notice, 3/5 is between -1 and 1, so the sine of the inverse sine is just going to be 3/5 times. Alright, so same kind of problem here that we did here. Okay, so take your inverse, which is the cosine, and it has to be between 0 and pi, so it's going to be on one of these two in the first or second quadrant. Well, that's good, because that's 4/5, so we know that is, if we draw our triangle, 4 here, 5 here, so that gives, if you use your Pythagorean theorem, that gives you a 3 there. Now, we used our inverse to get our reference triangle. Now use your reference triangle to find the sine, so that we can figure, you don't necessarily have to know what this angle y is, remember, but we can find out what the sine of that angle equals. And sine is opposite over adjacent, which would be 3/5 here. Okay, so this would be 16/25 plus 9/25, which is 25 over 25, which is 1. So this is taking some identities. This is throwing it all together. Okay. Now, what you should be noticing over the past several sections is that we're manipulating a lot of identities in ways that your mind probably didn't even realize we can manipulate identities. So make sure that you are paying attention to that and able to recognize that that's a difference of a cosine. Okay, so make sure you, the cosine of a difference. So make sure that you can recognize that. Alright, so the next video we have out of section 5.1 will be on the inverse tangent. See you then.